All right, this is Honors Algebra 2 Pre-Calc. We're doing 5.3 in Algebra 2. This is our fourth video in the series. We're going to talk about the zero product property and solving equations by factoring. Okay, so 0 is a really special number, and the reason 0 is a really special number is that, so over here we'll talk about this p times q equals 0, but let's think about numbers for a sec. So if I tell you that that a times b is the number, I don't know, let's say 2. Well, I don't actually know that A is 2 or B is 2, right? Because I could have something where like A is 2 and B is 1, right? Or A is 1 and B is 2. Or what if A were, I don't know, 1/2 and B was 4, right? Or what if I started throwing in negative numbers, right? What if A was -1/10 and B was a -20, right? So there's like infinite possibilities, right? So there's infinite options, right? And that's true anytime you multiply A times B and get a number that is non-zero. But 0 is special, right? So 0 is special. The only way to multiply and get 0 is if one of the numbers is 0. So if I tell you that A times B is 0, then either A is 0, and then B could be anything, right? So B could be anything, because for instance, 0 times 7, 0. 0 times 32.8, 0. 0 times -pi, 0, right? Doesn't matter. Or B is 0, and then A could be anything, right? A could be anything. So I could have 5 times 0. Well, look, that's a 0, and -42.3 times 0 is a 0. It doesn't matter. So 0 is a special number because if you multiply things together and get 0 out, one of those things has to be 0. There's no other thing you can multiply by. But that's not true for the number 2 or the number 8 or the number -7 or the number -482.8. It doesn't matter. The only number that this is true for is 0, which is why we have this thing called the zero product property, right? So the zero product property basically says that if you multiply two things together and get 0, then one of them is 0. We don't know which, but one of them is 0. So we can use this to solve quadratics. So let's say we have some quadratic function, right? So let's say we have a quadratic function f of x equals ax squared plus bx plus c. If we can factor this, right? So if we can factor this, then it's easy to find if we want to find the zeros, so if we want to find the roots, which are also sometimes called the zeros or the x-intercepts, right? We can set 0 equal to each of those factors, right? Factor number 1, factor number 2. So either factor number 1 equals 0 or factor number 2 equals 0, because based on the zero product property, one of them has to equal 0. So to show you what I mean by that, if we walk through just what's written down here at the bottom, right? So if we were to walk through one like this, an x squared plus 6x plus 5 equals 0, well, we can factor this in a number of ways, right? But hopefully whichever way you choose to factor, it doesn't take you that long to get to the fact that this is x plus 1 times x plus 5. So either x plus 1 is 0 or x plus 5 is 0, which means either x is a -1 or x is a -5. Okay, and those are the two roots of that expression, or the two solutions to that equation, okay? Which is kind of cool, right? Now, I do want to show you a side note, though, right? So as a side note about something that you can't do, okay? So I'm going to go ahead and put in obnoxious, big red, not okay. If I tell you that x plus 1 times x plus 5 equals, I don't know, 2, it is not okay to say x plus 1 equals 2 or x plus 5 equals 2, right? And the reason that's not okay is the same reason that when I gave you an example of what two things multiply to 2, there's no rule that says that if this is a 2, one of these is a 2. There's no rule that says that, right? There is a rule that says that if this is a 0, logically, one of these two has to be 0, okay? So just to show you it, that's why if you go back to the very first page of my factoring stuff that I gave you, so if we go back for just a second, all the way up to the top, I told you that the 0th rule of factoring was that if it's an equation, one side has to be 0. Now, there's always an exception to that, and it's usually like a trick SAT problem, and that's fine, right? Trick SAT problems are a thing that happen. But in general, if you're factoring, one side has to equal 0 unless it's a really obscure trick problem. And trick problems do happen, so it would be a lie to act like they don't. But again, we shouldn't base all of our mathematics knowledge off of trick problems. That would be weird and silly. All right, so let's go ahead and walk through an example 10. We're going to use the zero product property to find the zeros or roots or x-intercepts of each of these functions. So we're going to say 0 equals 2x squared minus 11x, because that's what it would mean to find the zeros. Right? It means y equals 0. I'm going to notice that this has a GCF of x, and what's left when I factor out the x is a 2x minus 11. So either x equals 0, that is one of my answers, or 2x minus 11 equals 0, so 2x is 11, x is 11 halves, or if you prefer 5.5. Please avoid using mixed numbers. Please don't use 5.5. Mixed numbers tend to just kind of mess you up in math. It's not that it's actually wrong, and I wouldn't mark it wrong, but I would discourage them highly. Same thing here. I want when g is 0, so that's an x squared minus a 14x plus 45. Again, I don't care how you factor, right? I don't care if you use guess and check or if you use product sum. What I'm doing while I talk to you is I'm saying what are the things that multiply to 45, right? 45 is a 1 and a 45. 2 doesn't go into 45. 3 does. It's 3 and 15. 4 doesn't go into 45. 5 goes into 45, and 5 and 9 is my winner, right? And I think that's probably what most of our gut instincts would have been anyway. So either x minus 5 is 0, which gives me x equals 5, right? Or x minus 9 is 0, which gives me x equals 9. So I get both of those answers. Cool. So let's go ahead and go to our next. So give a P10 a try. If you want to do it without me, go ahead and pause me. So I'm going to say 0 equals 3x squared plus 12x. I'm going to see that there's a GCF of a 3x, and I'm left with an x plus 4. So either 3x is 0, which when I divide by 3 gives me, that's a 3, my bad, x equals 0, right? Or x plus 4 equals 0, and when I subtract the 4 over, I get x is negative 4. Over here, 0 equals x squared plus 4x minus 21. Right, so I'm guessing that when you saw 21, your first thoughts were 3 and 7, and notice that because they have an opposite sign, we're subtracting, right? We're subtracting to a positive 4. So again, I don't care how you factor, but this is going to be an x plus 7 times an x minus 3, and you can FOIL to check. That means that either x plus 7 is 0 or x minus 3 is 0, so when I subtract the 7s and I add the 3s, I get that x is negative 7 or x is 3. Cool. All right, let's go ahead and keep moving forward. All right, so we're going to solve equations now using the zero product property. So remember, if it's an equation, one side has to equal 0. And you're asked to solve by factoring. I'll be honest, I wouldn't necessarily solve b by factoring, but you have to solve a by factoring. So let's walk through. One side of this has to equal 0. So I'm going to be honest and tell you that I prefer, so I like, me personally, I can't swear what everybody else likes, I like a positive leading coefficient. The reason I like that is all that guess and check stuff I taught you where if the back seat has a minus, then it's opposite signs. That doesn't really work well if you have a negative leading coefficient. So I'm going to add the 15x squared to both sides to move it over. If you had chosen to move in the other direction, it's fine. I would just suggest that you factor out a GCF of negative 1. Okay, so move this over. Now, again, I don't care how you factor, right? Factor by grouping, or factor by a product sum and making it grouping, factor by guess and check. I say, okay, cool, this is either a 15x and a 1x, or it's a 3x and a 5x, right? This is either a 1 and a 4, or it's a 2 and a 2, right? And this tells me that they have opposite signs. So, looking at my options, I think that if I could get, that's a 12 and a 5, that's not going to do it. That's a 6 and a 10. Hey, that's the winner. Okay, so it's going to be these guys, right? So I get a 3x and a 5x, right? If I put the 2's here, I recognize that this is going to give me a 6x, and this is going to give me a 10x. Since I want them to subtract to a positive 4, I need the 10x to be positive and the 6x to be negative. So this will be a negative 6x, right? Negative 6x and a positive 10x, and sure enough, there's my 4, right? equals 0. So either 3x plus 2 is 0, which is going to give me x equals negative 2/3, or 5x minus 2 is 0, which is going to give me x equals positive 2/5, right? Those are my two answers. Now, for B, you were asked to solve by factoring. So we're going to solve by factoring, but then I'm going to point out that because there's only one power of x, you could do this in an easier way. Here you have to pretty much factor or use another method that we're going to learn in 5.4 or 5.5. But for this one, you could actually solve using SADMAP because there's only one variable power, right? So there's only one power of x, that's the word of, my bad, x, right? So I could technically use SADMAP, and I know that it said solve by factoring, so I am going to solve by factoring, but just to be clear. So if I were solving this by factoring, I notice that there's no GCF, but it is a binomial, and it is one of those special binomial patterns. This is a difference of squares, right? So I could factor this into a 2x plus 3 and a 2x minus 3, which means either 2x plus 3 is 0, which is going to give me an x is negative 3/2 because I subtract the 3 and divide by 2, or 2x minus 3 is 0, which is going to give me the same answer but with a positive, right, because I add the 3 over. Now that's fine. If you chose to do this using SADMAP, I'm going to show you that this would be the same answer, right? I would start by doing subtraction and addition, which would mean I'd add the 9. I would then do division, right? So this is subtraction and addition, then I do my division and multiplication, and I divide by 4. When I take a square root, I have to write plus or minus the square root of 9/4. Well, that's going to be a plus or minus 3/2, which is exactly the same answer. So again, here you were asked to solve by factoring, but if there's only one power of x, you can use SADMAP, which is essentially just order of operations. All right, let's do a P11, and that's going to be it for 5.3. Okay, so again, I really like my positive leading coefficient. That makes me happy, so I'm going to move the 7x to this side. So 2x squared plus a 7x minus a 15 equals 0, right? So this is either a 2x and an x, or, well, that's it, right? This is either a 1 and a 15 or a 3 and a 5. I want opposite signs, right, which means that I need something that's going to subtract to a 7, right? Well, if I want to subtract to a 7, I'm guessing I want a 10 and a 3. So I say, cool, oh, my bad, sorry guys. All right, 2x and x, right? I want a 10. Sorry, didn't mean to write a 10. I was thinking 10, meant to write 5. Okay, so I want a 10, which is why that's going to be my 5, right? So that's my 10x. And I want the 3, and that's my 3x. Since I'm trying to subtract to a positive 7, I want the 10 to be positive and the 3 to be negative. So I put the minus here and the plus here. That's going to equal 0. So either 2x minus 3 is 0, which is going to give me x is 3/2, or x plus 5 is 0, which is going to give me x is negative 5. And those are my two answers. Same thing over here. If I want, I could use SADMAP, right? So SADMAP works here because there's only one power of the variable. But again, they asked you to factor, so let's do it both ways. So if I factor, this is a difference of squares. This is an x squared minus a 6 squared, right? That's a difference of squares. So I'd get x plus 6, x minus 6. So either x plus 6 is 0, which gives me x is negative 6, or x minus 6 is 0, which gives me x is 6. Great. If you chose to use SADMAP, you would start by doing addition and subtraction, and you'd add the 36 over. Then you'd get to the addition subtraction, my bad. You'd get to exponent because there's no division or multiplication. You would write plus or minus the square root of 36, which gives you x is plus or minus 6, which is the same answer, right? So either of those is fine. And that is it for 5.3.